So here is the comparison of the mass and the weight. First of all, you know that the weight is basically the product of the mass and gravitational field strength, and you know that the value of the gravitational field strength varies from location to location. It means that the value of the weight for each object also changes depending upon the value of gravitational field strength. But the mass remains constant because mass is the intrinsic property of the object. It's the fundamental property the object have. That's why the mass of the object remains constant, it does not change, but the weight of the object depending upon the gravitational field strength varies from location to location. So it's given here, the mass of an object is always remains constant. However, its weight will vary depending on the strength of the gravitational field at different locations. For example, if I suppose that an object of mass 1 kilogram is placed at the earth and the same object is placed at the surface of moon. You can see the mass of the object is same. I take any object whose mass is 1 kilogram. First of all, I place it on earth and then after that I place it on the moon. Then you need to find out the value of the weight on both of these locations. You know that the weight formula is the product of the mass and gravitational field strength. So the weight at the surface of earth would be equals to the mass, which is 1 kilogram, multiplied by the gravitational field strength at the surface of earth, which is 9.8 meter per second square. So the weight on the surface of earth comes to be 9.8 Newton. But when I have to find out the weight on the surface of moon, I have to use here the gravitational field strength at the surface of moon, which is basically 1 over 6 times the value of gravitational field strength on the surface of earth. So there would be 1 over 6 times 9.8. Just calculate this value, the weight comes to be 1.667 and its unit is Newton. So in this way you can see that the value of the weight on the surface of the earth and on the moon is different. That's why the value of mass remains fixed on each planet, but the weight varies depending upon the value of the gravitational field strength. The same is given here. For example, when an object of mass 1 kilogram is placed at earth, its weight is 10 Newton because the G is nearly equals to 10 Newton per kilogram. Instead of considering 9.8 meter per second square gravitational field strength, here I consider 10 meter per second square. That's why the weight comes to be 10 Newton. But when the same object is placed at the moon, the value of the weight changes because here the value of G is 1 over 6 times the value on the surface of earth. That's why you get the weight which is 1.667 Newton. So in short, I can simply say that the value of the mass remains fixed, but the weight changes depending upon the value of the gravitational field strength. Here you can say that I take the different object, for example, a cylinder, book, and a ball. All of these objects have different masses. For example, for the cylinder, the mass is 2 kg. For the book, the mass is 3 kg, and for ball, the mass is 1 kg. When you calculate the weight for all of these objects, just multiply it with G, which is approximately 10 Newton per kilogram. So you get the weight for the cylinder, which comes to be 20 Newton. For the book, it comes to be 30 Newton, and for the ball, it comes to be 10 Newton. So for all of these objects, as the value of mass is different, the gravitational field strength is same on the surface of earth. That's why the weight for all of these objects would be different. Here is exam question that appeared in October-November 2020. A sphere P made of steel has a weight of 10 Newton on earth. Another sphere Q, also made of steel, has a weight of 10 Newton on Mars. Both of these spheres P and Q has the same weight, but these are placed on different locations. The P sphere is placed on the Earth while the Q sphere is placed on the Mars. The gravitational field strength on Earth is greater than the gravitational field strength on Mars. It is given that the gravitational field strength on the surface of Earth is larger than the gravitational field strength on the surface of Mars. Which statement is correct? Option A. The mass of the sphere P is the same as the mass of the sphere Q. B. The mass of the sphere P is less than the mass of the sphere Q. C. On the Mars, the weight of the sphere P is more than the 10 Newton. And D. On the Earth, the weight of the sphere Q is less than 10 Newton. So first of all, consider here, there is a sphere P that is placed on the Earth and its weight is given, which is 10 Newton. I can also write here the weight for the sphere P. After that, there is a sphere Q that is placed on the Mars. So I can simply write here the weight on the surface of Mars is 10 Newton. You know the formula for calculating the weight. Weight is equals to the product of the mass and gravitational field strength. Write this formula for the Earth and for Mars. I simply write here weight on the surface of Earth is equals to mass on the Earth times the gravitational field strength on Earth, and the weight on Mars is equals to the mass on Mars multiply the gravitational field strength on the surface of Mars. You have to use both of these formula. Here in all the statements, they actually talk about the mass and weight. So first of all, let's check the mass. ME is equals to weight on the surface of Earth over the gravitational field strength. And here the mass on the surface of Mars is equals to weight on Mars divided by the value of G on Mars. So first of all, observe here the value of G on the surface of Earth is larger than the value of G on the surface of Mars. And the weight on both of these planets is same. So when the value of weight remains same, it does not change. I can simply say that the mass is inversely proportional to the gravitational field strength for both of these planets, because here the weight is 10 Newton. When the weight value remains constant, the mass is inversely proportional to the gravitational field strength. So here the value of G on the Earth is larger. It means that when the value of G on the Earth is larger, the mass on the surface of Earth is smaller. What does this mean? On the surface of Earth, there is a sphere P. The mass of the sphere P is smaller. And on the surface of the Mars, the value of G is small. When the value of G is small, of course, here the mass would be large. It means that on the surface of the Mars, the sphere Q is placed. So the Q sphere has a large mass as compared to the mass of the sphere P. See the option. In the first option, it's given that the mass of the sphere P is same as that of the mass of sphere Q, which is incorrect because the mass of the sphere Q is larger than the mass of sphere P. In the second option B, the mass of the sphere P is less than the mass of the sphere Q. Here the mass of the P is less. That's why the correct answer is B. So let's see the answer and explanation next. It's given here the Mars has less gravity acting on the object. If smaller magnitude of force of gravity means that the gravitational field strength is creating the weight equals to the weight on the Earth, object on the Mars must have higher mass than the object on the Earth. Means that the mass which is placed on the Mars, which is sphere Q, it has larger mass than the sphere P. Answer A is incorrect because here it's given that the mass for both of these spheres is same, which is not correct. Answer C. Let's see the answer C. Answer C is that on the Mars, the value of the weight for the sphere P is more than 10 Newton. So let's see this. Answer C is incorrect because the weight of the sphere P on the Mars will be less than its weight on the Earth. It is because of the reason the smaller force of gravity is acting on it. Similarly, the answer D is incorrect because the weight of the sphere Q on the Earth will be larger than its weight on the Mars because at the Earth, the large force of gravity is acting on it. That's why the correct answer is B, which is that the mass of the sphere P is less than the mass of the sphere Q. Here is another exam question that appeared in May-June 2021. An object of mass 2.0 kg is taken from the Earth, where the gravitational field strength is 10 Newton per kilogram, to the Moon, where the gravitational field strength is 1.6 Newton per kilogram. Which row is correct? So here you can see in the options the weight on the surface of Earth and on the Moon is given. You have to find out the weight on the surface of Earth and on the surface of Moon. Use the same formula that weight is the product of mass and gravitational field strength. The mass of the object is same, which is 2.0, but the value of the gravitational field strength is different. On the Earth its value is 10, but on the surface of Moon its value is 1.6. So just use this formula and find out the weight on the surface of the Earth and Moon. Let's see the answer and explanation. Here you can see the weight on Earth. It is equals to mass times g, which is 2 times 10. So the weight on the surface of Earth comes to be 20 Newton. Similarly, the weight on the Moon is 2 multiplied by 1.6 because 1.6 is the gravitational field strength, which is 3.2 Newton. See these values. On the surface of Earth the weight is 20 Newton while on the Moon the weight is 3.2. According to that, answer D is correct. Let's see answer D. Here the value of weight on the Earth is 20 Newton and on the surface of the Moon it's 3.2. That's why correct answer is D. Here are some questions that you need to solve, and these are for your practice. The mass of a person is 40.5 kilogram. How many grams are there in his mass? You actually have to convert the kilogram into gram. Question number 2. A body of mass 1 kilogram has weight 10 Newton at certain place. What is the weight of 100 gram, the weight of 50 gram and the weight of 32 kilogram? Question number 3. The force of gravity on the Moon is said to be 1/6 of that on the Earth. What would a mass of 15 kilogram weigh? I hope you understand everything very well. If you find any difficulty, you can ask. Thank you.